Hey guys, just want to do a quick go through of the end of year paper for Science Express Physics. Okay, all right, first question over here. Most of you actually got it. They actually ask you to explain why is it better to use a vernier caliper to measure internal diameter. Mainly, you got to mention about the word internal jaws. Okay, that's the main difference. You cannot just say it has something that can measure. Don't repeat the question. Okay. So basically, a vernier caliper has got internal jaws that can measure internal diameters. Okay, so next one, how do we measure the reading over here? So first one is 2.1 plus the one that intersects is the number uh, 4 over here on the vernier scale, so 2.14. Okay, how to improve this from our pendulum for measurement of a period? Take 10 oscillations or 20 oscillations. That's the first part. You got to mention about taking the average here. Okay, so next one, you got a motorcycle accelerating from rest. You got a speed time graph. 2 to 9 seconds over here. Constant gradient means constant speed. What about 9 to 10? 9 to 10. This is accelerating or decelerating. So speed going down, so decelerating, but the gradient is getting less steep, right? So it's decreasing deceleration here. Okay, so first 2 seconds, calculate, just use the formula for acceleration. A equals v minus u over t. We get 36 minus 0. You can see, you just read here 36 minus 0 divided by 2. That's it. And the resultant force acting on a motorcycle, whatever you calculate here, just F equals ma. That's it. 150. Where do we get an M here? M is here, is given as 150 kilograms. Okay. Next part for question part C, they ask you motorcycle engine produces a forward force of 5,000 newtons in the first 2 seconds. What's the friction? So if there's a forward force of 5,000 newtons, okay, because we know, what do we know? We know resultant force here, right? 2007. So for it to have resultant force 2007, I must have a friction of 2,300 newtons here. So front force labeled 5,000, rear force labeled 2003. Okay, over here, how do we plot? Okay, so travels accelerate uniformly to a speed of 20 meters per second in 30 seconds. So you can see 30 seconds here, boom, because constant acceleration, because constant gradient, right? Then after that, I tell you travel uniform speed of 20 meters per second for how many? 30 seconds here. So 10, 20, 30. Then after that, they say decelerate non-uniformly. So you can actually draw like that or like that. As long as this here, this part here is not a straight line, we'll give it to you. Okay, so 2 marks for that graph. Okay, the last part, bus negotiates a band. Okay, there's 2 parts to the question here. You can see they ask you first, explain what is meant by the term velocity. Some of you actually mentioned still distance. Okay, the key word is you got to say displacement changed, okay, for unit time. After that, you can explain using why velocity can change while speed remains the same, because displacement changes, okay, so resulting in change in velocity. Okay, question 4. I think there was actually an error in this question. The error which we asked you to rectify was calculate the density of both the scuba diver and his equipment, right? Okay, so and his equipment, so density is just sum of the masses, which is 80 plus 15 divided by sum of the volume. That's it. Answer 117.5. We'll give it to you, even if you round up to 3 fig 3SFs. Using your answer, what will it sink or float? So seawater is 1001. So since this is more, diver will sink. You gotta explain why. Okay, some of you just said it will sink. Okay, you get 0, as good as not answering, right? So you gotta see, explain if you will sink or float. So you'll sink because it's more dense. Gotta say that. Okay, question 5. Calculate the mass of water directly above. So before that, directly above the person, this is 0.5 meters square. They really give it to you. Couple of you actually 0.5 times 0.5 again. Okay, you don't need to this is not length. Okay, this part here is the area, which is what they also mentioned here in the question. So you need to read the question, right? Okay, so this is the area. So total volume is just 50 meters times 0.5. Answer 25 meter cube. That's the first step. Second step, just mass equals density times volume. That's it. Density given for water or seawater 1001, volume you found out here. So what's the pressure of water on the diver? So pressure is just force over area, which is weight over area, which is mg. W equals mg, right? Mg over am is given here, which is what you calculated already, times g10 divided by area 0.5, which is given to you in the question. That's it. Okay, question 5. We've got this thing here. You got a pivot. So anti-clockwise moment. This gives you anti-clockwise equals to clockwise moment here. All right. So some clockwise, they ask you to state the principal moment. Some clockwise moment equals some anti-clockwise moment about the same pivot. Couple of you missed this out, so you don't get awarded the credit, right? Okay, so the force exerted, again, use what I just mentioned. Clockwise moment equals anti-clockwise moment. Get force of 300 newtons. So how do I make it more efficient? They basically have a longer handle. Many of you just stop there. Have a longer handle. No, this is a 3-mark question. So you need to, they say describe and explain. So how do you explain? Explain using principle of moments. That's it. Longer handle gives me what? Larger moment. So larger moment will result in larger force. Okay, or you can say place piercing tool nearer pivot, so it causes a smaller moment, result in larger pulsing force. Same thing. You need to equate it back to the question, which is they're asking you, how can you cut effectively? To cut effectively, you need a larger force. That's all. Okay. Question 6, I think quite a few of you got this good. Okay, just force times distance, work done. So force is given here, 300 times distance, 0.2. And power is just work done divided by time taken. So time taken already given as 0.4. That's it. Okay. Question 7, false, true, all false. So the only one, evaporation can occur only when there's heat source? No, this is boiling. So both boiling and evaporation involves change in state? Yes. Boiling also occurs at the surface of liquid? Yes. Boiling occurs only at 100 false. For all liquids, they said. So different liquids, different boiling point, right? Rate of evaporation increases with humidity. No, with increased humidity, rate of evaporation actually decreases. More difficult because there's really a lot of humidity means a lot of liquid, particles in the air. So during both boiling and evaporation, there's an increase in internal kinetic energy. No, not necessarily. Okay. Mainly boiling, no increase, only increase in internal potential energy. Okay. All right. So over here, 8A, how do we draw? First step, equate same distance, image same distance behind the mirror. So this thing equal this distance. Second step, boom, all the way straight to the person, and behind the mirror, make sure it's dotted. Then from this point, go up. Okay, then measure. Somebody measure this whole angle. This whole angle wrong. This is not the angle incidence. You're going to divide into 2. So it's 34. I'll give you plus minus 2 degrees. Okay. Measure and label. So you need to label. You need to know where is it. As in, you need to draw the normal, right? So 2 properties, can draw any of these 5. Basically, selection of any 2 direct from textbook. Simple. Okay, so what's wrong here? An object is placed at distance 5 cm away, so you got the focal points here. Okay, there's one thing I forgot to draw. Can you guess what it is? Okay, just check it out. Just give me a sec here. Yep, you guessed it. It is nothing more than my arrow. That's right. Okay, let me try to just fit it in. Come on. Okay, you see, not very nice my arrow, but I think you get the hint. You get the idea. Okay, so you gotta draw your arrows in. So this is 2 cm, this is my focal point. So parallel, focal point. And this is boom, right? So this is, you gotta draw the image. Okay, so what's meant by term focal length? So you gotta have these 2 terms inside. Optical center, principal focus. So distance between optical center, principal focus, that's it. Okay, so part B, the object is moves closer to the left. So you gotta read the question. Describe how the image changes, not what the image is. So how it changed? So it changed. We went through this in class. Larger and further from lens, from 5 to 2 cm. At 2 cm, changes to virtual. After that, 2 cm to 1 cm, it gets smaller and closer, right? So closer to the lens. Okay. All right. So section B. Okay, just got to know. Okay, I think we mentioned this before. Answer 2 questions only. You answer all 3. You only mark the first 2. Okay. So over here, I've told you so many times. You see a couple of you don't draw the line. You gotta draw it out. Okay, some of you just use this, whatever this line is again. Okay, we don't stop here. You gotta follow my red marking. Okay, you see my red marking, you just shift it out a bit. Yeah, okay. So my red marking here, this is 8 cm because 1 cm represents 10 newtons, so this 80 newtons and downwards. See, 80 newtons, 15 newtons, so 8 cm, 5 cm. So you can see the top line is longer than my bottom line. That's it. So after that, just draw the parallelogram, dotted lines, and from the start to the end, measure it out. That's 4.5 cm, gives me 45 newtons. Okay, so they ask you, why does it hover at that height? Okay, it hovers because so you're gonna mention 50 Newton force balances the weight. In other words, there's no resultant force, so object remain at rest. Principle of conservation of energy cannot be created or destroyed, only transform from one form to the other. The drone's battery needs to be charged fully. So what is the changes that take place? I gotta read this properly. From the instant the motor is switched on. So once switched on, what happened? Chemical potential energy. Some of you use electrical energy. I'll give that to you. Okay, so what changes? Okay, you can see it starts to move. That means from not moving to moving, change kinetic energy. Okay, then finally to gravitational potential energy. Why? Because it is gaining height, right? Okay. All right. So suggest and explain improvement of design to improve the stability. Most of you could get the first part right. Either landing gear further apart, shorter, lower the center of gravity. No problem. But you didn't explain. So remember you went through this in class previously also. The explanation for all these is good. But the main thing is so that my vertical line through the center of gravity will not fall outside the base area so easily. So it will always cause it to tilt it backwards. Because once it falls outside the base area, it will topple. In other words, unstable. Okay, so now we got a cool pack here. Okay, describe the direction of thermal energy between the cool pack and the can rings. Okay, so you mentioned about convection currents and all that. So the question is very straightforward. They just ask you direction. So from where to where and explain. Okay, so the theory we're looking for is thermal energy transfers from higher to lower temperature. So it's always from hotter thing, which is the can rings, cooler thing, ice pack. That's it. Okay, so this one after 8 hours, temperature is now 10 degrees Celsius. So how do we draw that? Okay, so it actually increases the temperature. This is changing state to liquid, from solid to liquid for the ice pack, and after that it moves up. Okay, so if I place my ice pack at the bottom, what's going to happen? So place at bottom, no convection current. Some of you explain this one mark here for very long. You get 3-4 sentences just to explain that one point. So this is the easiest way. Just say, if placed at the bottom, I don't have convection current. So how does thermal energy actually get transferred to the ice pack? The only way, conduction. You can mention that. I give you the second credit, but you can explain further about conduction, the third credit, which is air is bad conductor. So very, very slow if I put my eyes at the bottom. Got it? Okay, part C again. Okay, we bolded for you. What is the change? And some of you talk about forces, intermolecular forces, and all that. No, no, no. We don't need to go into that. Okay, they just ask you read the question. Motion and arrangement change. So from -15 to a salt to a, was a liquid, right? So liquid at -5, right? So you can say at the start, vibrate faster. After that, move away from fixed position to sliding past into irregular movement arrangement. Then after that, start to slide past each other, faster speed. That's it. Okay, question 12, last question for the day. Okay, light pass through